Flanagan, and I'm with Geophysical. I'm a field geophysicist here doing a DCIP survey for sterling metals. DCIP survey it stands for direct current induced polarization. So the first half of that is direct current. We actually do both at the same time. So we have a full array, a big grid of receiver stations, and then we take current and we inject it into the ground. We have a big generator and a big transmitter, which is what turns the power on and off. And basically the power travels through the ground to all these stations and we can measure the voltage. Now that can help using math and physics, that's the physics of geophysics. We can find conductive bodies. So that's the first half. The second half, IP, induced polarization, comes from, we actually turn this power on and off on a 2-second interval. And all the metals in the ground and all their ions align with the current. So basically all the positive charges and all the metals will align. And when we turn the power off, it dissipates, and we can actually measure by sampling at 150 samples a second to see how fast or how slow that current and the alignment will go to zero. And then we can find what's called chargeable materials, and that's a lot better for finding disseminated or scattered bits of metal around in the ground. So basically, the farther we can get the entire line, the deeper that we can, and the more power we can push, the deeper we can see into the earth to find these conductive and chargeable materials. But if, for instance, you were interested in a more higher definition, shallow survey, you would have the station spacing much smaller. So the largest station spacing on a survey I've been on with Diaz has been 250 meters. And that was for, we were able to push a lot of current, and it was a very large scale project. But I've been on a smaller one for an engineering firm that just wanted general ground properties, and our station spacing was only 7 meters. So they wanted much more high definition, shallower information. Diaz has a patented system called the common voltage reference, and basically we can connect all our receiver stations along one wire, and they can all reference back to one node, because they have to make a dipole and they all have to reference back to one. But in other IP systems, that is separate and they aren't able to use one wire, so they'll sort of have two big stations and a wire connecting, and then they'll have to disconnect and reconnect to another two big stations, and it's just a lot bulkier than our system. Well, an easy answer is terrain. Our lines are straight, so we have to go to every single station, and that means not going the easiest route or the traverse. And for example, this survey has a lake, so we need to take our receiver lines directly in a straight line across the lake. Another answer is sort of crew management and trying to figure out who excels in what role, and then trying to keep them doing that so we can all find our place and keep it moving forward. Also problem solving. A lot can go wrong when you bring electricity outside, and it likes to. For a current wire leak, we do something called a leak test, and we hang the wire in the air, and since air is not conductive, we shouldn't be able to push any power at all through the wire, but if power is getting through, that means current is leaking out somewhere else, which can affect the survey because we need to know exactly where the electricity is pushing into the ground. But by doing that, if we turn on the power and we are able to push electricity during a leak test, then we can sort of see where the voltage spikes in our nodes, because they're all receiving the data and measuring the voltage and reporting back to the tent. Diaz also does MT surveys, which are magnetotellurics, and that's a passive monitoring system that measures electromagnetic fields in the ground, and it measures like ultra high frequencies, so its recording time is 24 hours, and basically you have to record, pick it up, process the data, check, and then you might just have to go back and set it up for 24 more hours. So IP is a bit more real time than that, which is a blessing. I'm really glad to be working here. Except for one day, the weather has been absolutely beautiful, so that definitely speeds things up. It's beneficial for the equipment and the crew morale, and yeah, just I have really liked the terrain here. I'm working here, less steep than other places, less wet than other places, less cold so far. It's been really nice walking. This is the second client I've had that I've actually spent time with. Usually we see them in passing or we talk just through emails. So it's been really nice to get to know you guys and see your faces. We've had some helpers from Sterling to help us get the survey along, and they're all extremely hard workers and very quick learners. Overall, like the vibes are great, the morale is great. Everyone has been so kind.